Hello, this is Mr. Collier, and today we're looking at the gradient of functions, of nonlinear functions, which is basically equal to the derivative, which we'll formally define later. So if we take a look at this graph of this parabola, then we can see, like at this point here at the vertex, if you draw a horizontal line here, the slope of the tangent line here is equal to 0. Okay, now somewhere along here, if you were to draw a tangent line, you get a slope of 1, so let's plot that. Then we get a 2, and over here we get negative numbers like -1. And what you get is a perfectly straight line, actually. So that's a graph of the slope here. Okay, and we'll prove that later. Later we'll be able to prove that this indeed gives you a straight line. Okay, here, the next one, let's graph the derivative here, or the gradient. So the gradient here is 0, and here it's also 0. Here we have, like, say, positive values, like +1 is here somewhere. Okay, so we get a thing here. Here we have negative values, like -1. And here the slopes are positive, like +1. And actually this looks like a cubic function. I know that the slope of a cubic gives you a quadratic, and we'll be able to prove that again later when we formally define a derivative. Here we have a straight line, so that's pretty easy because the slope is always a constant number. Looks like about 2 if this is to scale or something, so you just draw a horizontal line because the slope is a constant. Okay, and the next one, around about here somewhere, we got a slope of 1. Then it gets smaller and smaller, the slope. And here the slope is really, really, really big, so it's like slope goes off to infinity up here. So you get this shape, and later we'll show that if you got y equals ln x, then the derivative is 1 over x. We'll be able to prove that later, but that's what you get. Here this looks like a sine curve. Let's take a look at this. So here the slope is 0, slope is 0, slope is 0, slope at this point is 0. In between somewhere we've got a, or actually right there in the middle, we've got a 1. And here the slope is -1. Here the slope is -1. So this is this graph, right? So the original graph looks like sine x, and the graph of the gradient gives you cosine x, and we'll be able to prove that again later. This looks like an exponential function, and what happens here is you get a small slope here, then a larger positive slope. Okay, so you get this, you get exactly the same thing if the original function is y equals e to the x, or if it's like y equals 2 to the x, then you get a slightly different version, but still exponential. Okay, so you get an exponential graph of the gradient from the exponential function. Okay, so let's take a look at this one here. Again, this is cubic, so you get 0, 0. You get a quadratic if you start with a cubic. For this one we have 0, 0, 0. This looks like a quartic function. You get a cubic from a quartic. Okay, sketch graph where the function is greater than 0, but the derivative is always less than 0. So that means the tangent lines are always negative. So this is a decreasing function, and it's got to always be positive. So I guess you could draw something like this. This is decreasing, but always decreasing, but always positive. Okay, let's try this next one. It's negative, but always increasing. Well, you can simply draw something like this, right?